So some of you might remember last year during the Christmas holidays, I introduced the greatest YouTube series of all time, which was live integration. We took this Madass booklet from Team Madass Integration Megamix, and we just got a random number generator to give us some integrals to do, and then we did the integrals. Now I've stepped it up this year because I have bought myself a tablet, which means that I can do this by writing stuff down on a whiteboard. So 463 is the first integral we'll do, and I was always nervous of doing things on a tablet. Even when the channel started, 463 is all the way down here somewhere, because my handwriting is so terrible that I thought I was better off doing everything in PowerPoint, which is still a concept that I agree with, but I'm just going to see whether or not, sorry, there's going to be some rustling while I move stuff around there, to make sure I have the pen while we see how bad my handwriting actually is in a whiteboard. So 2 over 1 plus the cube root of x is the first thing I'm going to do. So we're going to use this whiteboard here, 2 over 1 plus x to the third. We could write that as dx. I can already see my handwriting is pretty nonsense there. So this is going to be u equals x to the third. So du equals a third x to the minus 2/3 dx. Okay, so this becomes the integral of 2 over 1 plus u. May have been better to do the substitution with a 1 plus, but we can fix that later, just in case. Okay, well that means that dx is equal to 3x to the 2/3 du. And x to the 2/3 is u squared. So maybe the substitution 1 plus wasn't the best thing to do, because this makes 3u squared on top du, like this, with a times in between. That seems pretty doable, if I'm honest. That seems pretty doable because, well, actually, so it was better to do it the other way. Now let's make the second substitution, m equals 1 plus u, which is obviously linear, so there's not going to be any change there. M on the bottom there, and then, of course, u squared is m minus 1 squared dm. And now this integral is quite trivial, I think, because we would just expand out the m's to make m squared. Divided by m is m. Minus 4, I guess. I've lost this 3, haven't I? There should be a 3, so let's put the 6 there and cancel this. So it's minus 2 lots of m over m, and then plus 1 over m, which is m to the minus 1, and we're going to integrate that with the 6 here, so it's m squared with a 3 minus 12m plus 6 log of m log, and then we're just going to put in m is 1 plus u, and then u is root x. This will be 3 into 1 plus x to the power third, and then so on and so on and so on. Cool. Anyway, next one then, I think that was fine. Next one is 550. So we're getting the big numbers. We're getting the big numbers straight away here. So 550 is going to be all the way down here. Let me just do a tiny bit more scrolling until we get to it. Hopefully it's not too scary. Cos of log of sine, cos times log of sine. So, I mean, substitution here, right? Because when you have that cos sitting on its own randomly, so cos log sine is the question. I'm going to be fairly archaic about, or anarchistic, I should say, about when I'm going to use cos log and when I'm going to use ln. It's basically just whatever my brain happens to write, and we'll just deal with it. Yeah, like u equals sine x is surely going to go well, because the whole point of that is when you do du, you get cos x dx, and then you have a 1 over cos when you replace the dx, which will cancel with this cos. So we end up integrating log of u, there's the ln straight away, log of u du, which of course is u log u minus u, just because I know that, and then we can put in the sign, and we'll end up with that question done. Okay, so scrolling this up a bit, so we have some space, getting out another one. I don't think I'm going to do too many of these because, you know, you don't want to give people too much of a good thing. You want to keep it nice and short. You always want them wanting more, right? So I'm going to stop integrating when you all want me to do 1 or 2 more, just because that way you'll definitely watch the next episode as well. X cos 6x, well, that's just integration by parts. I don't think that there's any point in me doing that. I can just do it. Can I just do it in my head? So it's a 6x, sorry, because cos integrates to straight to sine, yeah. A 6x sine of 6x minus the integral of a 6th sine of 6x, which makes a 36, but plus of cos 6x. And then it's just what I said the first time. So that's not hard. Okay, that was 187, so we'll do another one. By the way, when we get to easy ones, I'm just going to essentially say what the answer is and move on, which I think is probably what most people would prefer me to do. But if you really want me to write down them all every time and everyone feels like that, then I think that's what we should do. Tan x over tan x minus sec x looks interesting, for sure. So let's do integral of tan x over tan x minus sec of x. So we'll just maybe write a t over t minus sec dx. It was sec, right? I think it was sec. Now, a bunch of things we could consider here. But probably the best, or what I'm going to consider first is, what if we just said this was sine over cos minus 1 over cos? Because then these causes all cancel. And you get sine over sine minus 1, which feels like it shouldn't be hard. So, yeah, why is it not obvious what to do here? So, because surely I can just make a substitution. No, because the substitution won't cancel nicely. I can't break it up because the denominator is wrong, but I wanted to do that because the substitution. Okay, so we have the integral of sine of x over the integral of sine of x minus 1 dx. And like I just said, this should be really easy. Like this should be really obvious what to do. Maybe it is obvious to you. What if we just do the substitution? Because then what I'm concerned about here is that the dx is just going to get in the way. Because the dx is going to give us that same 1 over cos of x that we just saw. And I don't have a nice way of writing cos of x, and I don't have anything for that to cancel with. So that just seems like a bad idea. Oh, but what if no, that still doesn't work because that cos x still gets in the way. Okay, so what are my other ideas here? I don't want to do a t formula on this. That really doesn't seem worth it. I could times it by sine x plus 1, top and bottom, because that will give me sine squared plus sine over. Now, if I times that by sine plus 1, I'll get sine squared minus 1, which I guess is minus cos. So that's, if I just move the board, oh, don't know what happened there. If I just move the board, that's minus cos squared. So we end up with integral of minus tan squared minus sine cos to the minus 2. Now this is doable, right? Because the integral of minus tan squared, so tan is 1 plus sec squared. So this is minus 1 minus sec squared minus sine cos to the minus 2. Now that's obviously minus x. Sec squared integrates to tan. And this integrates to cos to the minus 1. And that's it. And I think that will be the answer, with a plus, because the minuses cancel. I think that must be it. I probably made a mistake, to be fair, but someone's going to tell me if I have, so I don't need to worry about it too much, do I? Next one is 261. I think this will be the last one we do. So 261 will be here, not too far away. Where is it? There it is. Okay, I mean, this feels kind of similar to what we just did, except the substitution is actually going to work. X squared over x minus 2. Sorry, I just moved sorry if there was a movement there. X squared over x minus 2 dx. Like, I mean, like the substitution just works this time. I think we've done one similar to this, right? U equals x minus 2. It's a linear substitution, so all of this du stuff is going to be the same. And x squared is u plus 2 squared. And then, of course, we just expand out and integrate. So u squared over u is u, but integrates to u squared over 2. And then plus 4u is just plus 4, so that's plus 4u. And then plus 4 over u is plus 4 log u when we integrate it. And then we put the x's back, and we're done. Since that one was so quick, I probably should have just done that in my head. We will do one more, which is 440. So we'll just pass 440. Where is it? It's all the way. Oh, I just missed it. There it is. Okay, I think I've talked about integrals like this in the past, which is setting myself up for failure because I can't remember what I talked about when I talked about them. So it's cos, I've actually already forgotten. Was it 2 cos over cos plus sine? Was that what it was? Let me just find out. Sorry, waste of time. 2 cos over cos plus sine, it was that. Okay. Now, we could consider a substitution. Again, like the u equals sine of x is potentially quite a good one to use here because it would cancel the top cos, but then the bottom cos, which is in the cos plus sine, doesn't do anything nice. If we times this by cos minus sine top and bottom, we're going to get a cos squared minus sine squared on the bottom by difference of two squares, which is cos of 2x, which seems helpful but probably isn't because we don't have any doubles at the top, because we'd end up with 2 cos squared minus 2 cos sine, which is actually a double. So maybe, so maybe this is fine. So we have 2 cos squared minus 2 cos sine over cos squared minus sine squared. Now I'm going to have to be a bit less lazy with my notation here, because what this is the same as is that's the same as cos of 2x, and now if we split the thing in half, we'll end up with 2 lots of the integral of cos squared over cos 2x. Now that's the bit I'm more worried about, because this here is sine 2x, and of course sine 2x over cos 2x is tan 2x, and I know that I can integrate tan without too many problems. Now, is cos squared over cos 2x something that I can easily do? What I was thinking was I can write cos squared. Did we not have it earlier? Was it a half plus a half cos 2x? Was that it? Because, should we run through that super quickly? Cos 2x is cos squared minus sine squared, which is 2 cos squared minus 1, which we add 1 divided by 2. I think that's it. Okay, now if we put that in there, we end up with, I think that 2 only goes over the first one. It does. So we end up with, well, the 2's are great, so they go away. So we end up with the integral of 1. We don't. Yeah, we do. 1 plus cos 2x over cos 2x. And we can do the whole thing again, where this splits in half here to make the integral of sec 2x plus 1. And then, of course, this integral still exists. And this is log of, tan integrates to log of sec. Now, this 2 means that there needs to be a half there, I believe. And then, of course, this thing integrates to, well, sec squared integrates straight to tan, so that was going to be a half tan 2x plus x minus this a half business. And I think that's that done. Thank you so much for watching. I'm sure I made a ton of mistakes there, which people are going to delight in pointing out in the comments.